Okay. Physical therapist interested in studying the proportion of adults that receive a physical therapy treatment. Physical therapist states that the proportion of adults that receive physical is less than 0.30. So that sounds like an alternative hypothesis. The therapist claims that the true proportion is less than 0.30. So if we'd like to test the physical therapist claim with a hypothesis test using a significance of 0.10, which of the following choices are true? There's a 10% chance we will conclude p equals 0.3, but is in fact less than 0.30. So alpha is this area in the rejection region. Okay, so this is 0.10. Okay, that means there's 10% area over here. And what you do with this whole rejection region, drawing like the bell-shaped curve business, is that a hypothesis test starts by assuming what we don't want to prove. We assume HO, and I think actually Newton uses HA, same thing. Okay, but for the null, it has to be HO. Okay, that the proportion is equal to 0.30. So we're assuming that the proportion is actually 0.30. We're going to get a test statistic. And if the test statistic lands in the rejection region, we reject HO in favor of HA. So there's 10% of that area is in that rejection region. Okay, so there's a 10% chance that if we assume the null hypothesis, if we're assuming that p equals 0.30, there's a 10% chance that we actually find out that we get a number that indicates that p is less than 0.30. Okay, so let's look at the ones that have us assuming the null hypothesis. It looks like this one right here. Okay, there's a 10% chance that we're going to get a test statistic that lands us in this rejection region, where we would claim that p is less than 0.30, when in fact HO is true, that p equals 0.30. Okay, so that's kind of a tricky concept, but remember, when you're doing hypothesis testing, we kind of assume the opposite. Somebody tells us you want to test that the proportion p is less than 0.30. Well, let's assume that it equals 0.30. And alpha is that level of probability that we'll accept the fact that it's probably not 0.30. Okay, that gives us a 10% rejection. That's why if you make alpha smaller, you reduce the chances of making a mistake, of making like a conclusion that's not correct. Okay. You reduce the chance of rejecting HO incorrectly. Okay, because there's two different types of ways you can make an incorrect conclusion. If alpha is 0.01, then there's a 1% chance, loosely speaking, that we conclude that the probability is less than 0.30, when in fact HO is true and the probability equals 0.30. Okay, definitely a tough concept, takes some getting used to, but physical therapist is interested in studying the proportion of adults receives a... I think this is the same thing, right? Yeah. What is the rejection region? Move the blue dots to choose the appropriate test. It's a left-tailed test. Okay. Oh, and then we got to move this too. 0.10. Man, that's not fun, because it's hard to drag it to exactly where it is. Let me just double check. Alpha is 0.10, so that's the area of our rejection region. The physical therapist is still claiming that it's less than 0.30, so that's a left-tailed test.